this class we're going to sort of change places. Param will lead and I will assist. So again, the reason for that is the same as for inviting Sean, that is to demonstrate to you that, while I appear to be a delusional old man, there are some young people.
At least two other people who believe in it.
Who agree with me occasionally. By the way, this delusional old man is sort of a title given to me at one of the Boost people. So, sort of official, I guess.
So I guess we had, in the class before last one, we were doing the Smalltalk and Fortran code samples, which many of you did interesting things with, which we will talk about in the second half of this class. Before that, we will spend some time talking about interfaces. And I mean, as I think someone demonstrated in describing the Fortran code, thinking about interfaces is, is often ignored. And I think I said some things which don't quite demonstrate competence. But regardless, we will talk about interfaces and how we should think about them. But before that, I hope you all enjoyed Sean's talk and what he was saying about looking at your code, figuring out what the algorithms are, etc., etc. But we've heard some. I mean, I've heard at least one person say in the last week that, hey, this was, he wasn't saying this applies to C++. He wasn't saying use the STL. I mean, yes, use the STL if you're using C++. That was not what he was saying, right? If you remember his first main point, it was no raw loops, right? What does that mean? That doesn't mean instead of raw loops, use the STL, because STL, of course, has implemented all algorithms. That is not what he was saying. What he was saying was, in your code, try to identify what the algorithms are and implement them separately, or at least decompose your code in such a way that they, so that you can understand it, so that you can implement those algorithms. And if you can implement them generically, well and good, but that doesn't matter, right? If you can only implement them with a specific type, that is still worth doing, because that is the only way we have of understanding code. And otherwise, as programmers, as day-to-day, we write code, right? What is the primary challenge when you're writing code? It is, how do you organize it? How do you, how many lines of code can you really understand when you're looking at it? Maybe 7, 14 on a good day, maybe. Or if you're really smart, maybe a page, where a page, of course, a page, I have to be careful here. How much is a page? The God-given page size that came to us from the ancients is 80 by 24, of course, right? The DEC VT100 was 80 by 24, and that is good enough for us, right? So, but 24 is really pushing it, right? 7, 14, maybe, right? So when you're writing code, the primary challenge really is, how do you decompose your problem into these small pieces that you can reason about, write correctly. And so the primary way we have of doing that is to recognize these data structures and algorithms and decompose our program using that. That's the only hope we have for doing that. You have this processor that can execute 1 billion instructions per second, but you cannot understand 1 billion instructions. That doesn't work. So, yes, Alex.
Just sorry that I barged in. The reason we are talking about it was that apparently the following thing happened after Sean's talk. One of the managers was talking to one of the lead developers, sort of reviewing his code, and he said, "Oh, shouldn't you try to eliminate raw loops from your code?" And the lead developer said, "But this is Python. They have no STL in Python." Or at least so we were told. So, and again, I think it's a very important point to remember that rotate makes sense in Python. It might not make sense in Prolog. There are some things which, outside the pale, but in any language you are going to use, rotate is a primitive. Rotate existed before STL. Rotate will exist after STL. C++ will disappear, but rotate will stay. So what Sean was trying to say is that you have to learn to identify these algorithmic primitives, right? And if you don't do it, you generate the code. Remember the code he was showing from Google? You will be like the best Google programmers, right? So this is the point. This is why we decided that's the starting point. It is not about C++. In general, the whole point I have been trying to tell people for many years without much success is that languages are secondary. The primary things are algorithms and data structures. And recognizing these primitive algorithmic pieces, not the language constructs. Language constructs do not matter. They're froth. They're
a means to an end.
They usually, as it usually happens, they're not means to an end. They're something which makes it impossible to understand the code. More language constructs people invent. Like another bright person comes to me and says, programming will be different. They have lambdas in C++. Well, yes, there will be even more incomprehensible code. I'm not saying that you should never use lambdas, but it's not, again, I repeat, it's not about lambdas. Unless you learn algorithmic primitives, you're not doing your fundamental tasks. Sorry for that.
No. So again, coming back to interfaces, right? As we talked, the primary task we have is to decompose what we're trying to do into small pieces, and of course, we have to call these things via interfaces. And what happens when you have bad interfaces? I mean, I think you've all been in that situation. You start writing some code and you figure out, oh, I need some data here that's only available outside that function, and now I have to jump through hoops to get to it. Or you're reading a function and there's no way to understand it without understanding the complete details of this other function because, hey, there's this side effect it has, which of course means it does something completely different. Or you need something in the outer function that isn't quite exposed by the inner function, and so maybe you have a shared pointer to it and you count references, and I mean you end up with a mess that is hard to understand. And instead, if you are able to decompose your problem, right, you end up with easy to understand pieces that you can reason about in an isolated fashion, you can implement in an isolated fashion, you can read other code that uses it and figure out what it's doing, right? And so really interfaces are critical. So let's enough philosophizing, let's look at some real interfaces and see what we can do, right? Okay, so this is a story I have been told that in the mid-90s, object-oriented databases were all the rage. It was the next thing that was going to take over the world. So one of these object-oriented database companies worked on this API for
all of them. All of them. Okay, since sorry, I apologize.
You can't tell it right,
We'll go back to just this story to get it right. In 1995, I was invited as a consultant to attend object-oriented database consortium. They were coming with a standard object-oriented database interface, and since I'm this famous guy, this was my 15 minutes of fame. STL just became part of the standard, so they invited me to review their interfaces. And before we go, one first interface we wanted to review was an interface of how to do find.
Right, so the task was you have some predicate, you have some container, you want to see if there is something in that container that matches that predicate. And since this was all object oriented, of course, you did this by calling a method on your container, right? So the interface was something like this. Right? So you called it the find if method, you gave it a predicate, and it would return true or false depending on whether it found something that matched the predicate or not. So if you were there, what would you say? Well, what do you think about this interface? What?
Are we throwing away information that we could possibly use?
Can you be more specific? What would you do about what's wrong with the interface?
It's not assuming that there's an accessor that will actually get the thing that you have found in some way, then it's at least not thread safe.
Why is it not thread safe? It is
It's
perfectly
not-
thread safe.
Why is it? I mean, it could be doing its own locking or something. Right? Why is it not thread safe?
When you exit find if, and something already has the handle to the thing that you have just found and deletes it, and then you go and access it, fully aware of the fact that it's in there because you just found
No, but
it.
then no interface could do anything about that.
Yeah, that's a
If you
high
write
level.
bad code, it is nothing will help you. But let's assume, do not try to complicate the stuff. Do not try to think in terms of what happens if evil people come. No evil people, it's just an interface. So why is it? Jerry has an idea.
Yes.
It might be better to return an iterator of some sort rather than a bool.
It might be better to return an iterator of some sort. Why would you want an iterator?
Presumably, you don't just want to find if there are elements, but you might want to actually operate on those elements.
Exactly. You find something, what is the next thing you might want to do? You might want to look at what you've returned, what you found. You might want to change what you found, So again, there are many choices here, right? We could return the object. Is that an acceptable alternative? So I mean, what about?
Before that, I think that finding it and looking at, let us try to do an example. Predicate is rich. You're trying to find a rich person because you are asking for money. You're a politician running for some office. So you find a rich person and it turns bull, there is a rich person. Now, you probably want to know his phone number. Do you agree? No way you could get the phone number.
But if the operations you are interested in are operations on containers and not on items, I mean this API is not in a void. Maybe there has item and get item. So if mostly I'm interested in, from all the containers I have, which container has a rich person, then this thing is perfectly fine if it has a sibling that says like get item or get iterator.
Well,
Except that
it's
you're
a-
gonna
How
make
would
it
you
work.
call it get
But
item?
it's not a find, it's a contains. You know,
Yeah.
this is not telling you either, and even if you return the object, then you still have the problem, what if you want to find another one?
So that's another how it's a linear search basically. And how do you continue your search if you found the first thing? That's another problem.
And if you don't operate on it by reference, then, I mean, if you don't get a reference, then how do you do any changes to it if you want to change it?
Right, so there are actually two things here. One is you might want to change the object, but another thing is you might want to change what the container contains. You may want to replace the position in the container that's containing this object with some other object. So it is actually not enough to return a reference to the object. You have to return a reference of some sort to the actual spot in the container that was found. So you do need an iterator here, right? Okay, so we know we need to return an iterator. Regarding Anil's other point of how do we restart a search, what do we do about that? What should the interface look like?
So you also notice the input argument is then insufficient because it doesn't tell you where to start.
Right, so the input arguments are insufficient. They don't tell you where to start and where to stop, right? So what should we do?
I have a question. So we are talking about database. We don't know anything about it, about the order and the way actual objects are stored. So that could be a cluster. The order can change from like every second.
It again, this is a specific. I mean, what their database was doing.
database people, long time before programmers, normal programmers, discovered notion of a cursor, which allows you to precisely, I mean, this, you know, those of you who know a little bit about C++ or STL, you know it like iterators. Cursor is iterator. You cannot do anything with databases unless you have a notion of a cursor, right?
It preserves the order or something.
No, it does not guarantee any order, but it allows you to navigate through the thing. Iterators do not tell you anything about the order.
So I agree, but I mean, if I provide the starting point, it would point to, I don't.
It has a notion of position. It has a notion of.
Again, they want, for whatever reason, a database, not just find a rich person. They want to find all politicians do. Trust me. They want to find all rich people and solicit them for money, take bribes, whatever way you want. I mean, you understand why I'm concentrating on these examples? Anybody knows? Or you don't read newspapers, I could see that. There's this thing in this country you might have heard called Supreme Court, the Supreme Court. And they just announced that rich people could bribe as much as they like. There is no upper bound. If Bill Gates wants to invest all his money into bribing politicians, he can do that. It's called freedom of speech. I mean, I'm just reporting what newspapers tell us. So that's why, so Bill Gates doesn't want to, or politicians do not just want to find Bill Gates, they want to find Zuckerberg, whatever. So therefore, they need some way after they found it in a database. Their users are, you know, all funded by these people. You agree with that? Right? So they want to find first, second, in some order. Otherwise, the most rudimentary things become impossible. Nobody really will buy a database if it has this, because it will restrict finds. You couldn't find Zuckerberg. Right? So, therefore, by the way, even those database guys eventually accepted my arguments, which shows that there is some hope for humanity. They were object-oriented people, but not totally clueless. So, now I insulted object-oriented. And it's going to appear on YouTube. Yes, the enemy of object-orientedness and all truth. But so, the interesting fact, again, let us go back. Param was on the right path and Daniel was on the right path. You want to restart, which means that you want to have some way of saying where you stopped before.
So how do we do that? Where did you stop before?
You need to pass it in. You need to pass it into the point, right?
Okay, you need to pass it in, but how? Like, what do we say? What is this thing that we pass in? You tell what it
The
is.
same thing that it returns.
The same thing that it returns. That
This is no. This is very, very important point. Yes.
If you want to continue to find, that's what you need.
Okay, so what would let's see.
Hi.
What would the interface look like? Oh, yeah.
Find next.
Find next,
Yes.
and then an iterator.
That's French for container.
Typing without seeing, especially in the eye.
Yeah, C will be the container.
Okay, so start position. What do we want to call this? Is this satisfactory? What do you say? Start and end. Why do we need end?
How do you know what is the end?
How do we know what?
Containers.
How do you know what the end is?
Container knows already, I guess. But now we have to somehow know start before we know start. So we need another function in container to actually have it.
To get the start.
Yeah.
You may want to search on not the full container, but some part of it.
Range.
You may want to search a part of the container. This is actually a very important point because often, this happens in string libraries pretty frequently, right? They'll have all these utility functions, but then sometimes you're dealing with a megabyte string. You don't want to search the whole string. You know you want to search this piece. You want to say find from this point to that point. So you need 2 endpoints, right? And so if you have 2 endpoints, I mean, does this still need to be a method? We've specified the 2 endpoints, and if the iterator already encapsulates the notion of iterating through the container, really this is really just a regular function, right? So we say start, or in STL terminology we would say begin and end. It's first and last.
Half an hour.
And predicate, is that
You don't need to change the name. Find if was a perfectly good name.
right? So we don't need a different function. I mean, find. We just first will be the beginning of the container when we call it the first time, and therefore it's find if. Okay, is this
Well, so there's a difference between, I mean, this works well for what we have with STL kinds of containers. But if you really had a database, the magic of a database is that order, you can change the order magically by simply saying, well, I want to do this index. And so if this was really for a database, you'd somehow have to, and perhaps the iterator would have that implied, where you would say, I'm searching this container with this index. And see, in the original find, the way they had simply said find if, order was not important because all you were going to say is it's either there or it's not. So you could say that about, in this table, is this here? But if you actually want to say from first to last, suddenly order is important, where it wasn't before. So now you have to say, in this table, given a certain order.
So, I mean, certainly if we want to traverse it in a certain order, we need to find a way to express that notion of iteration. So either it has to be captured in the iterator or then, So the underlying algorithm though is we are walking through these objects. The underlying algorithm is the same, right? So what I would say is you should implement all of these methods using this underlying algorithm. So if you want a contains, you can write a contains using this, right? You write this and then all the others you implement using this algorithm.
I mean, the problem with this interface, as it was started, it would actually possibly be better if we thought of what to return instead of bool, because then we could be lazy. With this interface that we now figured out, we can't be lazy. Our iterators actually have to be realized, and we have to have gotten them, and what if the database changes in the meantime or whatever. With the first function, what we can do is return a fake result set that is not yet realized, but is basically a future whatever, something, and then we can use that result set with the other methods of the API and basically construct a query that is then sent to the database.
You can do lazy evaluation, absolutely, right? But lazy evaluation is a higher order construct that is ultimately built on top of an iteration, right? You have to do this first.
But this would be implemented in the database, not in the interface to the database.
This would be a lower level interface to the database if you didn't want lazy evaluation. And if you wanted lazy evaluation, you could do it on top of this interface.
Yes, this is right.
Add something.
I just want to go to the next step.
Yes, let's look at the next one.
Let us learn simple things before we talk about lazy evaluation, whatever that might be.
Okay, so let's look at this again. We had an iterator, and we specified a range using 2 endpoints, first and last, and we said, do something with this range. Are there other ways of specifying ranges? Right, you can have a bounded range as in this case, or you can have a counted range, right? So that would maybe be called find if n. So a counted range is I give you a start point and then I say go n steps, right? So let's say you're working on an editor, you might want to say, okay, start at the first line that I'm displaying on the screen and look in the next 20 lines and find all instances of the variable foo, something like that. So there are cases where you are dealing with a counted range. You don't actually know the other bound, right? Okay, so we have counted ranges. Do we need a separate function for them? Should we just use the previous function for them? What should we do?
In this case, depends on what the iterator is.
Depends on what the iterator is, in what sense?
Well, if it supports addition with a number, a trivial, a fast advance, then we can use it. But if the iterator doesn't support a fast advance, then
right. So if it's a random access iterator in C++ terminology, you could just add n to first, and you would get last, and that's straightforward. But if it's an input iterator, then you're really in trouble. Or if it's even if it's a linked list, a forward iterator, you still need to. I mean, you can get last if you want to, but the time required to get last is of the same order as to do the operation in the first place. So you really don't want to get last and then call findIf. You want to have another function, right? So we need.
I would argue here.
Yes.
I would say that even if I have random access iterator, otherwise known as pointer, findIf n is a perfectly wonderful thing to have. I mean, we are somehow thinking in terms of, or if there is a transformation which would allow me to use the bounded range, I should always use it. Why? The thing which you just described the problem. I have a position and I have 20 more things I want to look at. It's a perfectly nice, clean, general purpose way of defining ranges. So why should we not use it everywhere?
That is true. It is a perfectly valid way of thinking about your program. So if you want a full interface, which you should want a full interface to basic algorithms, it would make sense to provide both.
Again, observe that sort of STL doesn't. There is no findIf n. But it's a mistake. It wasn't my mistake in this particular case. Originally I wanted every function to have all kind of variants possible.
But if in an imaginary world all iterators were random access, and you could always do plus n easily, then your argument, I don't know that the argument would be as strong. I mean,
It's not as strong, but the argument is that it's a different way of describing ranges. It's perfectly valid. This reductionist idea that you always want to have only one way describing ranges. I don't believe it. At least I don't believe it, and I don't think, think about your code. You often know the beginning and the number of steps. It's a natural way. Do you need to convert it? I don't see why. It's again what I'm trying to say that the perfectly legitimate way of specifying a range is the beginning point and the number of things. There is a duality between them. Sometimes you want one, sometimes you want another. But both of them are legitimate. At least, for whatever I know about these things.
Mm-hmm. So let's accept that. So the question is, okay, what should this interface look like? Do I just need to say this? Is this all I need to do? Do I need to change something else?
How about the return? The return?
The return. What about that?
You want to know how close you got to n, or how much you decremented n?
Why?
Why do you need to know how close to n you got, or how many items you got?
Because you may want to do findIf again, and you still want to be within that range.
You may want to do findIf again, and in the previous case,
I think there's something else, which is you need to have a way of saying I didn't find it. Because in the first case, if you return I that's equal to last, you're saying I didn't find it.
Mm-hmm.
But in this case, the caller can't tell when you return.
the caller doesn't know what the end is.
Yeah. is this equal to the nth position, meaning I didn't find it, or is it some n minus something position, meaning I did find it?
But
Caller can't-
Orion's argument
And
is still valid.
His is sufficient, but I think there's something you.
Right, even if we were to add, let's say a bool, that would not be sufficient, because if we wanted to, if we found the first one and we want to continue searching, we don't know what position at which we found something, and therefore how many more do we have? What should be our next call?
We do know the position where we found it. What we do not know,
We
as
know the
Ryan
posi-
observed, is how many
many
more
we have
steps
confused.
are left.
Right.
So why not change the interface to be find if that gets how many items I want to get, and it will traverse the list until it finds the number.
That's what we have.
That's a,
N is how many items. N is how many steps I want to do, not how, and then I may find. The most I can find is N items that match the predicate, right? But I'm saying if we change.
No.
So this
No, this is not the problem we're talking about. The problem is that we want to examine the range, which starts at first and has n elements.
Right. So if we care about how many elements we return, instead of specifying the range, let's specify how many elements we want to get back.
that's not
What
that's
would-
not the same problem.
I understand, but so Ryan's argument was let's return the number of items, elements that match the predicate, right?
No.
Okay.
No, how many you have
Position.
left to get to the end of the range you were interested in?
No, actually not even, well,
But okay, so Ryan, what is your specific proposal? What should we
I'm
return?
gonna return
A
a
pair of I and N.
Right, a pair of I and N. So it's not sufficient to just return, oh, I found the fifth item, because then you no longer have a pointer to it. You need both, right? You need a pair, if I spelled it correctly, of I and N. Right, and now we have all the information that we need to tell if we got to the end, to continue the search if we need to. And so this illustrates a bunch of general principles, right? Find if, there is no additional cost to find if, it should be called find if n. There is no additional cost here to return this pair, right? Find if n already knows what the item was. So returning the iterator is free. Returning n is also free because it is keeping account of how many items it has consumed. It has to, right? So there is no additional load we are putting on find if n. These are both useful things that find if n computed, and they should be returned because they are useful to the callers.
could we sketch both pieces of code for find if and for find if n? I think it would be instructive.
Let's start with find if.
You could put end. Start first.
I think that would be it.
The interesting fact is that whatever we have, we return. We observe the state of the algorithm here. What we have first and last. There's nothing else. There are no more variables involved. Well, there is p. We could return p, but we really shouldn't. Why shouldn't we? Right, explain to us.
We copied it. We didn't
Because
take
the
it by
guy who called us
Pass it
knows
in.
p. We should not return last. Why shouldn't we return last?
And then the last as well.
Yeah, he knows last. Never return what the guy back, what the guy gave you. He already knows it. It's a very, very simple principle. So first could have changed, and we're returning. Now let us look at the next one. It's exactly dual, while n is not equal or while. Curly. Huh?
First I. So observe the same thing. Okay, so here there's a question of what are we returning? The number left or the number consumed? But we can do both equivalently, really.
The number left, because then you can just call find if n immediately again.
And
if you had tuple unpacking, that would be true.
And you do, right? C++11 has this tie thing which lets you do that.
Oh, yeah.
So, yeah. Just to clarify what we were talking about, in C++11, you can do things like isn't it like this? Well,
We need to close the break.
This is the fragment. So if foo returns a pair of A and B, they get assigned to a pair of two things. They get assigned to A and B. It's supposedly, I have not actually used it, so this is all hearsay.
It's in our code base. It works.
Oh, maybe Boost already has it, but yeah, now it's in the standard. So now you are, officially authorized.
Observe the trivial thing, which is whatever the state we have, we return. Which is we do not lose any information. So we return it to Ryan, who could do whatever he likes. And in his case, he wants to restart. He doesn't need to do anything. He probably needs to bump in.
Yes.
And he might even want to bump first. But, that's among friends, it doesn't count. So,
do we care that we might not have n items left in this container?
That's on the caller, that's bad programming.
Well, but if it's
The iterator can't tell you that.
If you don't know how long you can increment first, you are in trouble.
There's a precondition saying
the amazing thing, he did not object to the first interface, where the same thing obtains. I mean, how do you know that first last is a valid range? Or that's a precondition. If you call me with invalid range, the processor will melt. If you're lucky. Yes, right. The worst thing, nuclear explosions, all kinds of things. And nothing could be done about it. Guys,
No, but this is different.
we're going to have a lunch break in a second. And talk. Why is it different?
Well, in Paran's example, for instance, if you're talking about a screen editor and you're searching for things from this line for the duration of whatever the screen is, which is 20 lines, that may well span beyond the end of the file.
And so might this.
If you know the end of file, which is less, then no.
but only the caller can.
Caller could know. The algorithm cannot possibly know.
Of course it can. If you have first and last, then you can pass first and last and n, and have additional condition to stop.
But for a
early.
forward iterator, you wouldn't have last.
But even
Might
for
not.
pointers,
Or an input iterator. You
That's
wouldn't
the
have
for
last.
simple pointers, never mind some advanced things. I mean, what is the difference? These are identical interfaces. One basically says from here to there by 2 pointers. This one says by a pointer and a count. They're convertible to each other.
For some types of
For sometimes.
Always.
They're logically convertible to each other. Never mind input iterators and stuff like that. They are the same. It's just a way of specifying a sub-range of a sequence. And both of them could be invalid. These could be invalid. You say, how do I know? I wrote code like that. It's very easy to write a code which sort of you forget that these two things actually do not connect. I tried to go from one list to another.
You delete a line and you forgot to update your last, for example. I mean, and in the caller, you have to be careful about the range you pass in.
And that's why you have smart last iterators that actually figure that out before you pass.
I don't, you do. I mean,
again, you can do that. You can make your iterator more heavyweight, but then your iterator is more heavyweight.
no, you cannot do it. The fundamental thing is preposterous. If you have two lists, I could always give you a range which starts from the first list and goes to another list. And what happens? Some awful thing happens. It's just a bad call. No smart iterator. This is not, guys, I mean, once and for all these magic smart iterators, smart last, this is nonsense. Yes, it is nonsense.
I agree that for shipping release code it's nonsense, but for debugging, if you have a debug mode, for example, certain versions of the STL implement a mode which will detect all of these issues.
Yes, and they're useless. Okay, what I'm
They're
trying to...
extremely useful for detecting problems when you're running tests.
This is 2% of the problems, right? That if people need to learn to reason about algorithms, people need to learn, there are very simple rules which says that, every container from the beginning to the end returns a varied range. That's the first thing. How do you get varied ranges? Then, the rule number 2, you have a non-empty range and you move the first position by 1. You get a varied range. And so on. This gives you inductive base to get all the varied ranges. If you get a varied range which is not obtained by these rules, you're in trouble. This is, some of you might remember I was talking about piano a long time ago. That you have to look at the inductive reasoning, not trying to use some magic invented by clever people. Yes?
I agree with you. I just think that programmers at some point in time need tools in order to help them decide whether
Yes,
they're...
that's the tool they need. Okay? It's called the brain. Okay? That is, I do not believe that people come and say, we will implement, it's like Microsoft guys said, we will eliminate pointers, no more pointers. Vector.begin will be in iterator, and it will eliminate math. No, it doesn't eliminate anything, because what happens is that all people, like, say, Hernan, who cares about performance, he doesn't use Microsoft, so he doesn't need to deal with that. He will observe that the iterators are much slower. So he says, therefore, what I'm going to do, I'm going to get an address of dereferenced first, a pointer, and use it. You say, Alex, you're making it up. No, I'm not making it up. I've seen reams of code like that in real companies, because people have to get rid of this idiotic stuff to get to performance. These people who write real production code, which is used by people. So any attempt to hide pointers from a programmer will fail. They'll get to it.
And tools can help, but ultimately you still have to be able to reason about your code to fix the problem. So you need to be able to do the kind of inductive reasoning.
It's insufficient for programmers to write code in the long term. I found bugs in other people's code using tools specifically like this, right? And I don't know how I would have found that bug otherwise. I'm not going to read the thousands of lines of code in order to find the bug. The tools found the bug for me.
I have to terminate the discussion because there is food which is getting cold.
All right, let's eat and we will continue after food.